So this is the fourth and final part of finding the equation of a cubic function. And in this one, we're given a tangent, and we have to find the equation of the cubic function using the tangent and really the main cubic function. So the fundamental areas here we'll be covering is using the point of contact and the gradient of the tangent to find the equation of the cubic function. By the end of this lesson, you should be able to not be intimidated by any equation where there's a tangent and you're asked to find the cubic function. So let's get into it. And we're given this exam type equation where the line y is equals to 4x minus 3 is our tangent, and we're given that n of x is equals to negative 2ax cubed minus bx is our cubic function, and we know that we're told that the tangent meets the cubic function at x is equals to 1. So that's really the x coordinate of point of contact. Let's call that POC. We know that it meets at 1, and we don't know what's the y value for that because it's a coordinate. So before we get into it, let's try and visualize what's happening here. Suppose we're given a cubic function and we're given a straight line. That's the tangent, and the tangent is nothing more than a straight line that meets or touches at one point and moves on straight forward. So they touch at one point only. So they touch at this point, and we're told that this point that we refer to as the point of contact is, we know that x is 1, we don't know what the y is. And we are told that this equation of a straight line is y is equals to 4x minus 3, cubic function n of x is equals to negative 2ax cubed minus bx. So really that's the main relationship that we need to observe. And also remember that the first derivative of n of x will be equals to the gradient of the tangent, right? Gradient of tangent. But what x are we talking about here? The x we're talking about is the x of the point of contact. So if we substitute 1 into the derivative of n of x, it should be equals to the gradient of the tangent. And what's the gradient of the tangent? It's 4. And how do we know that? Remember the standard equation of straight line is y is equals to mx plus c. So the m here is 4. So let's just really apply and consolidate what we just said here. So we said the first derivative of n of x, which will be, if we derive this, we should get negative 2, drop the 3, which will be 3a times x to the power of exponent of 3 minus 1 to give us 2, minus b, the exponent of x is 1. If we drop the 1, then you're going to have 1 minus 1, which will be 0. Any number to the power of 0 will be 1. So we'd just be left with b. And we said this is the derivative f of n of x. It's the first derivative of n of x. And we also said that if we substitute 1 where there's x, right? If we substitute 1, what's that 1? The 1 from the point of contact, we should get the gradient of the straight line. So we can say 4, which is the gradient of the straight line, is equals to negative 2 by 3. It will be negative 6a. Then we substitute where there's x. We substitute x value, which is 1. So we should have 4 is equals to negative 6a minus b. Negative 6a minus b. So that's really, you can see we have some form of equation happening there. So we can just label this equation 1. And now this gave us a hint that there actually needs to be a second equation. And how do we get that second equation? The second equation, we get it from the point of contact. This point of contact lies on both graphs, the straight line and the cubic function. So to find the y, we can find it by substituting these coordinates into any of these graphs. But we only have one complete formula. or one complete graph, which is the straight line, 4x minus 3. We know that the point of contact lies on this graph, so we can just substitute x so that we can find out y is. We go ahead and say y is equals to 4 times 1 minus 3, which would be y is equals to 4 minus 3, which would be y is equals to 1. So therefore, the point of contact is 1:1. So why is this important? This point of contact will help us to derive or to develop the second equation. And how do we go about it? We go about it by saying, remember we have n of x, which is negative 2ax cubed minus bx. And the point of contact lies on this graph as well. Because remember, this point is a point on both of these graphs. I'll just write it as 1:1. So we can substitute it on either graph. So we can just go ahead and substitute. Where there's x, we're going to substitute 1. Where there's y, we're going to substitute 1. So it's going to be 1 is equal to negative 2a 1 cubed minus b into 1. We're going to have 1 is equal to negative 2a minus b. And that's our equation 2. So we almost by our answer. And we just need to solve these equations simultaneously, which would be very simple. What we can do, we can just take equation 1 and make b subject. Right? How do we make b subject? We can take this b and take it to the left hand side to make it positive. Then we're going to have, being the 4 to the left hand side, we're going to have negative 6a minus 4. This will be equation 3. We can say substitute equation 3 into the unused equation 2. It means where there's b, you're going to substitute minus 6 minus 4. We can go ahead and do that. We're going to have 1 is equals to negative 2a minus 6a minus 4. Then we have 1 is equals to negative 2a multiply in with negative. We're going to have positive 6a plus 4. Then what do we do next? Just use a clever technique of just identifying the like terms with the sign in front of them. And just take the 4 to the other side of the equation. We're going to have negative 4 plus 1 is equals to negative 2a plus 6a. It will give us 4a. Negative 4 plus 1 to give us negative 3 is equals to 4a. Remember, we're solving for a. We divide both sides by 4, which will give us negative 3 over 4 to be our a value. And to find our b value, we just substitute into equation 3, y equation 3, because equation 3 already has b as subject of the formula, which is just mean we just plug in and play. So our b will be negative 6, substitute our a value, 3 over 4 minus 4. This will give us 6, 3 and 2 over there. Then we can just really 3 over 2 minus 1 to give us 1 over 2. And that's really a quick way of how to solve this. So we've calculated what our b value is, which is a half, and we've calculated what our a value is, which is negative 3 over 4. So to quickly summarize what we've just done is we've calculated our a and b value. So therefore, the equation of n of x is equals to negative 2 times, remember our a value is negative 3 over 4 x cubed minus our b value is a half of x, which means n of x is equals to the 2 and 2, keep it 2, and then that will give us 3 over 2 x cubed minus 1 over 2x. So that will be our equation of n of x. But the key takeaway in here is to visualize, when we talk about the tangent, how the tangent relates, the main graph. If you're given a cubic function, maybe next time a cubic function will be maybe of that nature, we never know. And the tangent will always touch at one point. You must always know that the tangent and the cubic function will meet at one point, and that one point is the point of contact, and will be given by x and y. And the relationship, suppose this graph is f of x, suppose this graph is g of x, you'd know that the first derivative cubic function will be equal to the gradient of the straight line being tangent, and you can substitute the x value of the point of contact into x to get the gradient, and then this will help you get the first equation. And you can use the coordinates of the point of contact and substitute them into the cubic function to develop the second equation, and that way you will solve the equations simultaneously. So if you found value in this video, please hit the like button and be sure to look at the next video series, where I'll be covering the application of calculus, rate of change, calculus of motion, and how to calculate the maximum and minimum when you're given applications of calculus.